Good morning, everybody. We'll just give people a few minutes to log on this morning and then we'll get going. So we'll just give it about 3-ish minutes and then I'll take attendance and then we'll dive right in. And see the PowerPoints and your guys' study objectives. Have you encountered any issues or is that all working for those of you who have accessed it?
I was wondering if I could ask a quick question about the research project.
Yes, go ahead. You mean
So
the requirement?
Yeah. So do we need to make an account for that, or should our login info for CSUS already be that login?
So you have to create an account. It is typically your CSUS login, but you still have to tell the system to make you an account. So I believe that when the first time you log on, it's hard to show you on mine because I already have an account. But when you go on the SONA website, kind of towards the bottom right, there should be a button or a link that says create new account. And that is what you want to access.
Okay, thank you.
I believe you can also check your Sac State email. And I think you emailed us like an account to like sign in with. That's what I signed in with. I got an email from you.
Oh, okay. Yeah, sometimes the course will auto generate that. So yeah, if that works, that's the easiest for you, basically, because you could just click on the link from the email. But you also can go to the SONA website too. But thank you, Stasia. Yes. James, did you have a question?
Well, I was just going to add that I just made my account last night and I had some trouble making it, but I figured out that email we were all sent. We all have like a custom password. So the username is our Sac State, whatever we use to log on in Sac State, but we all have a custom password. So that's why it's kind of difficult to log on at first.
Okay, thank you. So yeah, so everyone go it'll be in your Sac State email. So if you have a Gmail or a Yahoo, it's not going to be there. You'll have to go, because basically it's the system sending an auto-generated email for this. Because you're in a course that requires the research participation. So you'll have to go to your Sac State email and then you should see an email there, like James is saying, and it's probably like a temporary passcode type thing. And then you'll enter that and then it will create your account. Sometimes it takes up to 48 hours for the account to register. So don't be alarmed if it tells you, that the system is waiting on the account and you can't access it right away. That's pretty common. But if you've done everything correctly and you've entered your the special passcode for the course and everything like that, and it's still not working after a few days, you can let me know and I can reach out to the department to see what's going on. Good questions. Any other questions or issues?
Yeah, I have a question.
Yes.
As far as, because I'm trying to find it on my Sac State email, but I can't find the email they sent out.
Okay. It's not the only way to access this, I don't think. I don't send, so again, just to kind of reiterate with this whole requirement, I have zero control over this. It is, I know it's frustrating for you guys. It's frustrating for me as well. I don't send those emails. Those are coming from the department. I don't set the due date. I have no control over this. So like, I wish I could just resend you the email and I can't. So I'll reach out to Saba, who works in the department on this, and I'll let her know that some of you are having trouble finding that email and seeing if she can resend those. But if not, I think you can still create an account. using the SONA website, it just might take a little longer because you don't have that passcode. And Stasia is saying that her email came before school even started on the 19th. So you might have to go back quite a ways, Justin, to see if you can find it. Like it wasn't a recent email. It was a few weeks ago.
Okay, thank you.
Mm-hmm. Okay. All right, now I just have to remember where we were. I think we were on theory versus hypothesis. Can anyone confirm or deny? Do you guys remember where we were? Kind of, not really.
We left off on theory and hypothesis.
Okay, that's what I thought. So we talked about the hypothesis itself, right? What that is. Hang on, let me share my screen. So you guys can see what I'm doing. Okay, here we go. Okay, so I think if I remember correctly, we talked about the hypothesis, that basically it's our prediction, right? So if one thing happens, we predict that we would see a result of something else happening, right? So we're proposing kind of a relationship between two variables. So if we control one variable, which is the independent variable, okay, that's what we manipulate in an experiment, then we would expect to see some change in the dependent variable, right? So that's what we're looking at or what we're measuring in the end. So theory and hypothesis are two completely separate things. I think that a lot of people get these confused or think that they're interchangeable, and they are not. Okay, so the theory is something that states or predicts events in general terms, right? So again, I put this example, the diffusion of responsibility. So the greater number of bystanders in an emergency situation, the smaller share of responsibility, or the less likely it is that they're going to feel like responsible to help, right? That's the theory of diffusion of responsibility. Now the hypothesis, and as you can see that the theory is kind of a broad general statement, right? So we think that the greater number of bystanders, the smaller share of responsibility. Okay, then we actually test the theory, and that's the hypothesis, the prediction about something specific that will happen. So we say the more people who witness an emergency situation, so now it's not just bystanders, they're actually witnessing something happen. So imagine we put 10 people in a situation where they actually maybe watch a couple fight and it escalates to kind of an abusive situation, okay? You would only do that if the couple was confederates, which basically means they're part of the experiment and they're acting, okay? Because again, ethics, right? We can't have a couple actually hurting each other and fighting in a situation like this. But so if you actually put people in a specific situation, they witness it, our prediction is that they're going to be less likely to help the victim, right? And the more, we're also saying in the hypothesis that the more people we add to that situation, right? So let's say we start with 10 people and then we add 10 more, now there's 20, and then we add 10 more, now there's 30. Every time, each time there's more people witnessing the situation, then even less likely it will be that someone provides help. Okay, so the theory is kind of the overall, the general term of what is going on, but the hypothesis is a specific prediction of what will happen. Okay. So we're looking at general versus specific prediction about behavior. Okay. The next step is having to formulate your explanation, right? So you have your theory, you have your hypothesis. Well, first you have the research question, right? So that's the first thing. You come up with your research question, you have a theory, you formulate your hypothesis, and then you formulate your explanation. So you have to turn your hypothesis into specific testable procedures that we can measure and observe, because ultimately you want them later replicated by others. right? So if you can measure it, if it's something that you can define, you can measure it, you can observe it, other people can do that as well. And hopefully your work can be replicated down the line. Okay. So you have to specify exactly what it is you're measuring and how you're going to measure it. Okay. So if we're measuring the diffusion of responsibility theory, right? So if we have a hypothesis on that, you have to be very exact with what you're looking at, right? So you have to be exact with the number of people that are in the situation. Okay, we're going to start with an N10, right? Like a group number of 10 people. And you have to measure, you have to define exactly what help is, right? So we have to define, okay, help might be telling one or both of the couple, like, please stop fighting. Maybe we define help as actually stepping in between the couple, right? So maybe we say, no, we're not going to consider that our group is helping unless they actually physically intervene with this couple, right? They step between them. So you have to define exactly what it is you're measuring, and then you have to detail how you're going to measure it, right? Are you going to count the number of people that helped, the number of instances that they helped, right? Are you going to keep track of once one person helped or two people helped, do more people help, right? Because that's another theory of diffusion of responsibility. It is less likely when you're in a bigger group that people will help. But once more and more individuals start helping, you also see the larger group help more too. So you have to take all of those things into account, and you have to define all of that. Okay, so what you're going to measure, how you're going to measure it, where you're going to observe the behavior, right? Is this going to happen in sort of a naturalistic setting? Is this going to happen in a clinic setting where you have completely contrived the situation for everything involved? That is the most controlled, right? You don't have any confounding or interfering variables that are happening, which we'll talk about a little bit later. But you have the most control when you're in a clinical setting, right? Because you control everything, versus if you're out in the natural environment, sort of anything could interfere with what you have going on. But you do have to specify all of those things. And then any resources that you might need to successfully carry out the observation, okay, and to measure everything that you're measuring. How many researchers do you need, right? How many people are keeping track of all these things? And all of these specifics are being written down as part of your experiment so that someone else could read it and say, okay, I know exactly what they did. I can either change one thing to see if we get different results, or I can do exactly what they did because all of the instructions are right here, and I can hopefully replicate their work, right? Or if I don't replicate their work, we want to ask why. Why didn't I find the same thing? Okay, so there are lots of different ways to conduct research. So we kind of went over the method of how you conduct research, right? You come up with a question, there's a theory involved, you formulate a hypothesis, and then of course you investigate your hypothesis and document your findings. But there are lots of different ways to do this. There's not only just one way to conduct research and get information that you're trying to reach in as far as your conclusions go, especially when we're looking at human behavior and all of the things that we do throughout our life, right? There's so many different behaviors that you do have to look at these from different angles and possibly from different research methods. And all of these methods provide slightly different levels of evidence as far as the conclusions we can make from the findings. So I'll kind of go over that a little bit as well. So first, we have something called descriptive research, okay? And this includes a number of different things. It can include something like surveys or focus groups. So if you guys participate, if you decide to do the research participation for the requirement of this course, a lot of the studies you participate in will be these surveys or focus groups, right? So you basically take a survey, you're rating things like on a scale from, I don't know, strongly disagree to strongly agree, right? And everything in between, things like that, right? Or focus groups. Focus groups are where you're actually in a group, you're asked a series of questions, and the small group kind of talks about it and gives their answers. We also have naturalistic observations. So that is something You're basically just out in the person's natural environment and observing them. Okay, so you're not really controlling anything. There's no contrived situation. For example, you go to a daycare and you just observe children's play, right? Or if you're looking at a specific individual, a specific child, maybe you're going to look at their play and their interactions with other kids. But you're not interacting with them. You're not interfering. You haven't set anything up special. You're just showing up on a normal day. You're going to sit in a chair in a corner and you're going to observe them in their natural environment. Okay, so that's naturalistic observation. Case studies are another one. So case studies are one individual. So a lot of research in psychology and most other sciences as well. You have large groups of people, right? But there are case studies where it's sort of a longer study, usually done over years of time on one individual. And we'll talk about some examples later on of those. But so those are just some different types. Experimental research. One more thing I want to say about descriptive research. So generally, all of these things provide pretty weak evidence because pretty much all of these types of experiments within descriptive research have little to no control over what's going on in the environment. Okay, even on a survey, you have no control over, first of all, whether that person is telling the truth. Right? There are some questions that can be sort of triggering to participants. We have to be really careful with those as survey researchers because people might not want to tell the truth, right? Even though they're anonymous, and even though you'll never know who gave what answer, people still don't want to answer that, right? If you ask something like, drugs should be legal, right? That's a pretty polarizing statement. And then you have a scale of strongly disagree to strongly agree. People know that that is a controversial statement, a polarizing statement. You might have some people who truly believe that no, drugs should not be legal, period, end of story, strongly disagree. And you might have some people who will state their opinion and say strongly agree, they should be legal. But a majority of people are going to just reply, neither agree or disagree. Right? They're going to want to walk the middle line because that's a really strong controversial statement. So we have to be careful with those questions. And as the researcher, you have no control over whether or not someone's going to tell the truth on those things. In a naturalistic observation, you have zero control, right? Because you're not manipulating or interfering in any way. You're just sort of observing behavior as it happens in the natural environment, and anything can happen. Right or wrong, it doesn't mean that something bad's going to happen. It's just that you have no control over that behavior. Okay. And part of a good experiment is experimental control, right? You need to have some sort of control over outside interfering variables that you're not investigating. Because if you don't have control over that, how can you definitively say that your findings are due to whatever it is you manipulated? Right? You can't, because there's all these other things that could have happened in the environment that you didn't control for. And we're going to talk about those things a little bit later on in this unit, but you do have to control for those things in the environment as much as you possibly can. Okay. It's never perfect, right? Especially because we're working with human subjects in psychology. You can never perfectly account for everything, but to a pretty great extent you can, so that you can have a pretty high level of confidence, right, in your findings that they are because of the variable that you manipulated. Now, experimental research, so all of the problems I kind of talked about with descriptive research, experimental research provides the strongest level of evidence, right? Because we are controlling variables that are interfering. And this is typically done, when we collect data. So in my master's program, when we collected data, we're asking participants very specific questions before they even begin participating. And if they don't meet our criteria, they can't participate, right? So that's part of the control. If I'm using symbols that have Tagalog meanings, right? I need to make sure that my participants don't speak Tagalog, right? Otherwise they would figure out the puzzle very quickly, right? So that's one of the first questions I ask them. Do you read or speak or write Tagalog? And if at any point they say, well, my aunt does, or I might recognize a few words, or I've heard it before, I don't let them participate. I couldn't let them participate, right? Because it would throw all of my findings. And I could not definitively say that they learned this strictly from my procedure, because they could have learned it because they already knew Tagalog, right? So experimental research is very controlled and it provides the strongest level of evidence. Okay. There's other types of different research known as quantitative versus qualitative research. These are really easy to get confused. Quantitative, I remember this, there's an N in it versus qualitative, right? There's no N. Numbers. Okay, so think quantitative, think numbers. This involves numbers and calculations, statistics. Okay, so these are things like IQ scores, right? Key packs. So lots of basic research studies being done with pigeons, right? And they peck a key. So we can count those, right? The number of eye blinks, psychometrics. These are all numbers, okay? Percentages, things like that. You can measure the amount of time, right? You can measure dollars, you can measure amounts. So anything that is involved with any kind of calculations or numbers, we call that quantitative research. But these calculations, they can be objective. So they're objective. So objective versus subjective, which is something you'll hear me talk about. Objective means it's not someone's opinion. Okay. Math and calculation is pretty finite for the most part. Sometimes that can get a little wonky with statistics, but you'll figure that out in a statistics course. I'm not going to go too much in detail on that. But for the most part, quantitative research is objective. Okay. It's not an opinion. The calculations are pretty finite, and anyone could get the same results if they run the same numbers, right? If they do the same calculations. But we also have something called qualitative research. Okay, so these involve things like interviews and focus group, spoken words rather than numbers. Okay, so talking. These are mostly exploratory research, right? There's no calculations involved with these. These are scales and ratings. This is coding what people say. Okay, so that's another thing that we do, especially in interviews. So we'll have questions and we'll have a list of possible answers, and we'll sort of code how people answer the questions. But these are really subjective findings in their nature, right? Because there is no finite calculation you can do based on someone's verbal answer to a question, right? That's really hard to get a very specific calculation from that. So these are more exploratory, and typically qualitative research is sort of done as like a lead up or like the first step before you get to kind of the more quantitative stuff, right? So it's sort of like the start off to your question. It can provide you with very general and broad information, but when you want to get more specific, you often have to turn to quantitative research. Okay, so more exploratory with the qualitative, kind of a more general, broad research area there. There's also something called archival research. So this is when we use already existing data, okay? And this is being done a lot, especially during the pandemic, when we've been sort of shut down for the last few years. Lots of people could not do their research. Lots of master's students, trying to graduate and get their thesis done. They could turn to archival research and do projects on that, which was helpful. The one advantage of this type of data is it's really easy to collect because it already exists, right? And most people can find it on online databases of some kind. There are archival databases that people can input all of their findings and all of their data for large scale projects. So when you see things like huge studies being done like across, many states. Let's say they're doing like research on, I don't know, test scores in schools in third grade, in the US, right? Those are huge studies that are being done. All of that data is put into a database online, and you can find that archival research. As long as you usually have to be associated with a university and so on and so forth to get the data, but it's really easy to collect because it's already there. But some of the disadvantages, you are dependent on what's available, right? So you kind of can't ask any question, right? You sort of have to ask a question that the data already fits, because you have to use the data that's there. So you're kind of dependent on that. The world is not your oyster, right? When you're formulating your own research question and doing an experimental type research, the world kind of is your oyster. As long as you can figure out how to ask your question and how to control for outside variables and, figure out how to measure the behavior you're looking at, you're good to go. But if you're doing archival research, you are limited to the data that's already there. And it might be incomplete, right? But you wouldn't know because you didn't collect it. And often they will put disclaimers if there is a significant amount of data that was not completed, but for the most part, they don't. Right? If there were any issues with the data, if there were was anything missing or anything like that, they're not going to disclose that. It's just archival data. It might be disclosed if they wrote a paper on the data, but that is not always the case. That's not always available to you. So you really don't know what the circumstances were regarding data collection. Versus an experimental research project, you're the one collecting all the data and working with all the participants and developing all the things. You know exactly what went right and what went wrong. You know if you had to fix things or change things halfway through. You would not know that with archival data. Okay. So this research is useful. It's certainly useful, but ultimately it does provide pretty weak evidence, and you wouldn't want to form any definitive conclusions about things. Okay, there's no causal relationships. You could not definitively say this was caused by this. Okay, because your findings are only based on data that's already been collected. Okay. So naturalistic observation, I kind of talked about this a little bit, but this is where you just observe naturally occurring behavior. You don't make any changes to the situation at all. You don't interfere, you don't interact. You're just recording, just observing and recording. There is an advantage to this. It does provide information on how people interact and behave in their own environment with no interference. Okay. And ideally, when you're conducting a natural observation, you would like them to not notice you. Okay. So if you are going into, say, a school or maybe a setting with children, one of the best things you can do as a researcher is go in there for a few days or a week so they kind of get used to you, because they can behave differently in front of new people. If any of you have children in your lives, right? If you have kids or nieces or nephews or friends who have kids, you'll hear parents say all the time, right? Like they don't act like that at home, right? So my kids are perfect angels at school, and they're good kids. I'm not going to say that they're bad kids by any means, but kids are kids. But they're perfect at school. They listen, first time obedience. They raise their hand before they speak. They always say please and thank you. They're so kind to other kids. It's kind of like that at home, but not always, right? When someone is in their natural environment, they behave a certain way. And when you have other variables interacting on that environment, okay, the behavior changes, right? So when my kids go to school, there are other factors there. They behave differently. They don't behave as they would in their natural environment at home. right? So as a researcher, you have to take those things into account, that people might behave differently if you sit and watch them, right? So you do want to think about that when you are doing this types of observation. So that what that's called is called reactivity. It's behaving differently when you know you're being observed. I worked on a project in grad school where we were looking at people who ate really, really fast, okay? Rapid eaters, what they're called. And I know you hear a lot of people say, oh, I eat too fast, I eat really fast. But we're talking about people who could eat, you know, a burrito, you know, like a 2-hand burrito from Chipotle or something in 30 seconds without even thinking about it. That's just how they eat. They eat very, very quickly. But it's interesting, if we put someone in there who they knew was a researcher, they would make an effort to slow down, right? We didn't tell them to slow down. We didn't say anything. We didn't say, they didn't even know what the study was about. We had people volunteer who said, basically like, do you think you're a fast eater? And then we put them in a room with pizza and we were like, okay, we're going to have lunch. And then the researcher will come in and talk to you guys. So they didn't really know kind of what was going on, and we're just observing them eat. But if we put someone who they knew was a researcher in there, they would eat more slowly. If we put someone else in there who they did not know was a researcher, but they were, right? So we kind of tricked them. That researcher ate lunch with them, but was also observing, but the participants did not know they were a researcher, then they would eat very, very quickly, right? So we can have that happening where you have reactivity with the researcher and the participant, where they behave differently. So that's the main disadvantage of naturalistic observation, is you can get that reactivity. You also have no control over the environment. So there's no experimental control in these types of things, okay? But it does give you good information. If you are trying to get a gauge for what a behavior looks like for an individual, the best way to observe it is in the natural environment, because that's where you're going to see it the best, right? Just know that you have no control over the situation. Okay, survey research. So I kind of touched on a little bit about this, but this is where a small group of people, I mean, not small, but relatively small, smaller than the population, right, are chosen to participate, and they represent, their answers represent the larger population. Okay, so they're usually asked a series of questions about their behavior, their thoughts, their attitudes, you know, from very satisfied to very unsatisfied, or strongly disagree to strongly agree, or not likely at all to very likely, right? It's all those sort of survey answers that you typically see, right? This can be really useful information. And you can use a small sample to then make inferences about a larger population, rather than actually having to conduct the experiment with the larger population. Let's say you're trying to get, you know, information on, you know, mothers under the age of 17, right? And the resources that they utilized when they had, you know, their first kid as a teen, basically. You know, you can maybe get information on, I don't know, 500 people who experience that, even though, you know, there's tens of thousands of people across the nation. You can sort of take those answers, as long as you get a randomized sample and do all the things you're supposed to do. And you can use that information you gather and apply it to the larger population, rather than having to have tens of thousands of people come in and answer these questions. But it is possible for the sample not to be representative. So something we do is called randomized sampling. Okay, we do take random samples. And it is possible that your sampling doesn't actually represent the diversity of the population you're looking at, right? Another disadvantage, again, and I already kind of touched on this, is you have no control over whether or not individuals are reporting accurately. And we see this a lot when we're looking at more controversial topics. So, that is one, teenage motherhood, right? Like that's definitely kind of a touchy topic. People might not answer honestly, especially if they know maybe they did something wrong with the care of their child. They might not want to admit that, right, on a survey, even though it's anonymous. And of course, we don't use any of that against participants. None of the information is used against them or anything like that, but they still might not want to answer that question correctly or truthfully, right? They want to answer it how you think you want them to answer it, right? Any type of drug use, alcohol use, even sometimes surveys on like studying and stuff. Students might not want to admit how little they study and how little time they put into a class or into a project, right? If you're asking about something like that, about study habits, you just don't have any control ultimately over whether or not people are going to answer truthfully. So that is something that you have to keep in mind. And sometimes it can be really difficult to get the right questions on a survey. You have to test questions with different people. Ideally, you would test all of your questions with like a test group and see if there's agreement with respect to the scale that you're using. So does this even reflect, does the scale I'm using even reflect what the question is asking? You have to have negatively and positively worded things. So for example, a positively worded question would be, I think drugs should be legal, right? And you would either strongly agree or strongly disagree. But a negative version of that question would be, I don't think drugs should be legal, right? So now you're switching how the person would answer that question, right? And you have to do that to make sure that people don't just put strongly agree on everything. So you have to reword the questions, and then you should be testing them to see if there are correlations between people's answers and things like that before you even do the actual research. So survey research is pretty difficult to do correctly and accurately. It can be done and the information can be very useful, but it's not easy. I think people think, oh, it's just a survey, that'll be a piece of cake. And well done survey research is not easy. It's very difficult. We also have something called correlational research. So this involves studying the relations between two variables to determine if they're correlated, which means if they're related to each other or not. Okay, so we're looking at a relationship. We want to measure how correlated they are, or the strength of their correlation. So the strength of their relationship. And if you take a statistics course, you're going to learn all about the correlation coefficient and things like that. I just want to mention that this is how we measure correlational research. It ranges from -1 to 1. You do not have to know all of the in-between and all of the nitty-gritty of the correlation coefficient. I just want you to know that when we're doing correlational research, we measure it with a correlation coefficient that gives us the level or the strength of relationship our variables have. And the range can be -1 to 1. Okay. So if it's a positive correlation, right? So a +1, that means that both of the variables go together, essentially. They both change in the same direction, right? So that's a positive correlation. Either they both increase as one goes up, the other also goes up, or they both decrease. Okay, so if they're both going in the same direction, either they're increasing or they're decreasing. So let's say the more cell phone use in a car, the more car accidents you get. Okay, so that's a positive correlation, right? They're both moving in the same direction. The more you use your phone in the car, the more accidents you get in. Vice versa, the less you use your cell phone in the car, the less accidents you get in. Okay, so that's a positive correlation. Both of those variables are moving in the same direction. We can also have something called a negative correlation. This is when the variables are moving in the opposite direction. Okay, so let's say, let me think. Let's say a child is acting out in school. Okay, so we tell the teacher, okay, you're going to call on them, more often to answer questions, which is basically providing them with more attention. Okay, so as we provide that child with more attention, okay, that variable is increasing. They're getting more attention. They're getting talked to more in class. Their problem behavior goes down. Okay, so as one goes up, the other goes down. Okay, that's a negative correlation. They're moving in opposite directions. We can flip that around as well. The less interaction the teacher has with that child, if she stops interacting with them, if she stops providing attention, now that variable is decreasing, and we see the child's problem behavior start to go up again. Okay, they're changing in opposite directions. Negative correlation. And then, of course, you can just have no correlation at all, which means one variable does not affect the other. As one moves, the other one doesn't move at all. It means that you didn't find a relationship between those two variables. There was no relationship between them, okay? No effect. Okay, but as I mentioned before, correlation does not equal causation, okay? Just because we find a correlation or a relationship between two things doesn't necessarily mean there is causation. It doesn't mean that the change in this variable actually caused the change in the other variable. There are ways to further investigate that experimentally to see if it was the cause. But when you're doing correlational research, you can't say that it is the cause. It gets really problematic really fast. So let's say we're looking at two other variables. Let's say we're looking at the number of murders that occur in a summer, okay, and the level of ice cream sales that summer, okay. So let's say that we found a correlational relationship where as the number of ice cream sales increase, the number of murders decrease, okay. So in a correlational research, what that's saying is there's two variables that are changing, okay? They both happen to be changing. Ice cream sales happen to be increasing and murders happen to be decreasing. But does this actually have anything to do with the other, right? Probably not. It's correlational. We do have a correlational relationship, right? A negative correlation there. But is that causation? Is it that as ice cream sales increase, murderers are happier, so they stop murdering people, right? That would be causation. Okay, causation means that the movement or the change in this variable causes the other variable to change. So would it make sense that an increase in ice cream sales causes less murders to happen? I don't know. Perhaps we'd have to do some serious experimental research on that. But that's just a correlation, right? So you could actually have two variables, find a relationship between them and have it mean nothing, okay? And have it actually mean nothing because they don't have anything to do with the other. So keep that in mind with correlational research. You cannot say that you have causation, okay? It's just a correlation, it's just a relationship, but it doesn't mean that one caused the other. So here I have another example. These are just some fun memes that I have. But another example, so let's say we have the divorce rate in the state of Maine, okay? And then we have the consumption of margarine, okay? So fake butter, I guess. As you can see, we have a positive correlation here. So what does that mean? It means that both of the variables are moving in the same direction. Okay, positive correlation means they're both moving in the same direction. Here, they're both decreasing. Okay. So as the consumption of margarine goes down, we also see the divorce rate in Maine go down. Okay, they're changing in the same direction. They're both decreasing. But this doesn't necessarily mean that the less margarine that is consumed, the less divorces happen, or the less divorces that happen, the less people consume margarine, right? We have a correlation. They're both moving in the same direction, but they probably have nothing to do with the other. Okay. We could do some experimentation and find out, is it that people aren't consuming margarine as much? It's not as bad for you. Maybe they're healthier, they're more active. And maybe people are staying married because of that, you know, but we would have to do a pretty extensive experiment to look at that, or survey research or something like that to see if this is actually causation. But just looking at just this data and just these two variables, you cannot say that one caused the other. It's merely a correlation. Any questions about that? I know that correlation and causation can be a little confusing, so I want to make sure that I was really clear about that. Let me check the chat, just make sure no one's. Okay, okay, cool. All right. Another type of research, we have case studies. So I kind of mentioned this. So these are in-depth, intensive investigations of one person, or it can also be a very small group of people. Okay. So the advantage of this, it provides a really deep and thorough understanding of the participants. Typically, you are studying them for years. A girlfriend of mine was actually in a case study. It was a small group case study, and it was her and her mom. So her mom had a miscarriage, and then she got pregnant with my girlfriend and had her. And so the experiment was at UC Davis. This was many years ago, but they still do things like this. And they had a small group of women who had had miscarriages before and now had a successful, viable pregnancy. And so they collected data on those women all the way through the pregnancy, the birth, and then through, I think, the first 10 years of the child's life. So they're doing case studies on a number of things, but basically, birth after miscarriage and raising a child after miscarriage. So that's an example of a case study, right? So they followed my girlfriend and her mom, they check in like every 6 months or something, and they ask them a series of questions and things like that to collect data over 10 years of this small group of women. And they do this all the time, right? They'll follow a group of kids, say in a private school versus a public school, over from kindergarten through 12th grade, and look at like reading levels or something like that. And again, they have a small group of kids, and they'll meet up with them every 6 months, and they'll ask them questions. If it's a reading study, they'll actually have them read, they'll measure their comprehension, and they'll do that over the course of 13 years, right? From the age of 5 in kindergarten until they graduate high school. So that's a case study. So you get a really good understanding of participants. And it can also be done with one person too, where you follow that one person over years, looking at a specific behavior that you're investigating. The big disadvantage with this is results typically are not generalizable to a larger population, right? So remember, in survey research, we're doing really large studies in the hopes that you can generalize your findings to the larger population. In case studies, you really can't do that, okay? The findings that come out of this research are really in-depth and thorough, and they're extensive. You get a lot of information from these studies, but typically you can't then turn around and say, okay, you can't turn around the study that was done with the moms with miscarriage and say, apply all of that data and say, okay, well, all moms who had a miscarriage and then had a viable pregnancy experienced all of these things. Okay, you can't apply those small findings of that small group to the larger population. Okay, the findings are typically too individualized, especially if you're doing a single person case study. Okay, you're looking at very specific things for that individual, it can't be then applied. Your findings can't be applied to somebody else, right? Or other people in the population. So that's the biggest disadvantage of the case studies. Okay. So now we're going to talk about experimental research. So this involves the investigation of a relationship between two or more variables. Okay. So we do this by changing something about one of the variables. That's the independent variable. That's what we're going to change. Okay. And then we record the effects of the changes that result on the other variable or the dependent variable. Okay. These are some researchers here, Skinner, who did a lot of experimental research. All of the basic original experimental research, a lot of it was done with animals. The picture on the right with the monkeys, that was an attachment study, right? So if we give little baby monkeys who were taken from their mama, it's kind of sad. But if you give them kind of a soft like doll that kind of feels like their mom, you know, what is the attachment level like there versus if they only have like a metal, kind of like a metal doll that's not warm, even though it provides them food, right? So the metal contraption they have would provide the little monkeys with food. They still preferred the kind of soft, fluffy doll that felt like mama, right? So investigating the change of one variable from something you manipulated. Okay, so we're going to talk about these specifically. So first, the dependent variable, okay, the DV. This is the variable that's being measured, okay? It's the variable that's changing. It's your outcome. It's your result, okay? So once you have changed a variable, what is the result on your dependent variable? Okay, it's the outcome variable. It's your dependent measure. It's what happens after you make the change. Okay, so this is what we're measuring. It's your outcome. The independent variable or the IV is what you're manipulating. Okay, so that's the variable you're changing. In the experiment with the little monkeys, okay, the IV or the independent variable was the two types of dolls they gave the monkey. Okay, so they gave them a metal one, which was basically just like a food dispenser or like a milk dispenser, some cold metal milk dispenser. Okay, or the fluffy soft monkey doll. Okay, that's the independent variable type of doll, right? We're manipulating those. The experimenter manipulated. One is cold and hard and you know, just a little metal thing. One is fluffy and soft and feels like mama. Okay. The dependent variable, the outcome of that experiment, is the little monkey's level of attachment. How does that change if you manipulate what kind of doll you give them, right? Does their attachment level change if we give them the metal doll? Or does their attachment level change if we give them the soft fluffy doll? Okay. So dependent variable is the thing that you're looking at, that you're measuring at the end. It's the outcome. The independent variable is what you're changing, what you're manipulating. Okay. And then we also have confounding variables. So these are variables. It's something other than the manipulated IV that you have that could provide an alternative explanation for your results. You do not want to have these. If someone can say, well, you know, your results could have been because of this other thing, right? So in experiments that I worked on with in my master's, something we look at is the behavior of talking to yourself, right? How do you solve problems that are difficult, right? And so when we first started doing this research, a lot of criticism of our findings was, well, you don't take any type of measure of the participants' thinking. Because how can you do that, right? And the argument was, they're probably talking to themselves, but you haven't accounted for that variable. And that could be explaining your findings. Okay, that's a problem. That's a confounding variable that we did not account for. So what do we have to do? We have to make them talk out loud. Everything they're thinking, we want them to talk out loud. So we're constantly reminding them, tell me what you're thinking. Tell me what you're thinking. Tell me what you're thinking. How are you solving this problem? Tell it to me out loud, right? So that we don't have this confounding variable that we didn't account for, okay? You do want to avoid these at all costs, at all costs. Yes, yes. Mm-hmm.
Do people ever get like frustrated during the experiments and stuff? Because like I know I've been like hounded, like tell me what you're thinking, tell me what you're thinking.
Yes.
Struggling
Yeah.
with answers.
I've never had anyone get angry per se, frustrated maybe. I've had people say, well, I don't know what to think because I don't know how to solve it, right? And I'm like, that's okay. Just tell me that. Like, even if you're thinking, I don't know how to solve this dang problem, like, tell me that. Most participants just laugh and they're just like, they think it's kind of hilarious because it kind of is. It's weird to sit in an experiment room and tell this stranger who's writing things down about what you're saying, what you're thinking as you've solved this very weird problem that makes absolutely no sense. So I would say 95% of the time, me as the experimenter and the participant are chuckling, right? Like it's funny. But sometimes they get frustrated. Yes, that can happen. I'm trying to think of like another example too. Like, let's say, okay, so let's say you're doing a survey on stress. Okay. These are done a lot. So survey on stress, you have a bunch of different groups you're doing. So you do like half of your participants come in, and let's say it's 3 weeks before the semester starts. Okay. And you're able to get half of your participants done. But then you didn't have time to hold sessions as the researcher, so you had to schedule your participants for the first 2 weeks of school. Do you think that the answers on those surveys about stress are going to be different from the participants that were in the summer versus the participants in the first 2 weeks of school? Probably, right? All of these participants now are trying to take classes and figure out if they're going to get into their classes and making sure they have the right number of units. And then did they get their parking pass? And did they pay for all their credits? And so on and so forth. That's a huge confounding variable that you should have thought of the start date of school, right? So we could look at your results on the stress survey and say, well, these results could have been because of the answers they were giving, but it also could have been that they were super stressed out because it was the first 2 weeks of school and these answers mean nothing, right? They would have answered differently if it was during the summertime before semester started. That's a big confounding variable. So you would either want to make sure you did all of your participants in the summer or all of your participants in the first 2 weeks of school so that the answers are relatively the same and it's controlled for. Okay, so those are confounding variables. You want to make sure that you account for them as much as you possibly can. Sometimes you can't, right? If you're doing a survey on a sleep study, you could have participants answer a question that says, did you get a full 8 hours of sleep last night? If you didn't, you can't participate. But how do you even know that they're telling you the truth? Maybe they'll lie so that they can participate. And then their answers might be different because they're tired because they didn't sleep well the night before, and you can't control for that, right? So confounding variables can come up quite a bit. You can see how easily that can happen. But as much as you possibly can, you want to account for these and make sure that the findings are due to your independent variable and not due to anything else. Right. So here's some just quick examples. So let's say a researcher investigates whether giving students more time to study reduces test anxiety. Okay. So in this example, the independent variable is the amount of study time you give students, right? Because we can change that. It's what we manipulate. Okay. We can give them 30 minutes, or we can give them an hour, or we can give them 10 minutes. Right? So that's what we change. That's the independent variable. The amount of test anxiety that the student experiences is our DV. Okay. We measure that and see if it changes. Is test anxiety higher? Is the DV higher when we give them less study time? Is test anxiety lower when we give them more study time? Okay. Some extraneous variables, that might happen in this study, or confounding variables, right, that could affect your findings would be things like temperature of the room. Okay. Did you always keep the temperature of the room the same? Or was it constantly changing, right? If a room is hotter, you might have more test anxiety. People get hot, they start sweating, right? It can set your nerves on edge, right? Versus a cold room. Time of day, right? The time of day could influence their test anxiety, right? So all of those variables you have to take into account. So again, you would want to make sure that you're always taking your dependent variable measure at the same time of day every time, right? So if we're going to look at test anxiety for individuals, we want to make sure we gather that data every Friday at 8 o'clock, right? And make sure the room is always at a comfortable 68 degrees, right? You want to control for those confounding variables as much as you possibly can, so that no one can say, well, it was actually because of this other thing that you didn't account for. Okay. Here's another example. Could be investigating how manipulating the accuracy of feedback. Does this affect how people complete work tasks? Okay. So meaning, when you're teaching someone to do a task and you give them feedback, so you tell them like, that was, you did this correctly, or you did this incorrectly, right? What if we gave them the wrong feedback? Okay, so what if we gave them feedback that's 100% accurate, right? So every time they were right, we told them they were right. And every single time they were wrong, we told them they were wrong. Okay, we gave them 100% accurate feedback. How many tasks would they be able to complete, right? So the independent variable is the accuracy of our feedback. The DV is measuring how many tasks they completed. But what if we change our IV? Because remember, the IV is what you manipulate, it's what you change. Let's say we only gave them accurate feedback 50% of the time. So let's say they got 10 things right, but we only told them 5 of those things were right. And let's say they got 10 things wrong, but we only told them about 5 of those mistakes. Okay, so now we're only giving them accurate feedback about 50% of the time. We've manipulated that variable. Now how many tasks will they complete? Okay, so you see how the independent variable is what we're changing and manipulating. The dependent variable stays the same. We're just measuring what it is, right? Does it change? Okay, does it change based on what we manipulate? And we're just measuring it. Okay. So I've put another example in there. You can go over that in the PowerPoint on your own. Okay. So in an experiment, it typically involves 2 types of groups. Okay, we'll have a control group and we'll have an experimental group. Okay, and the experimental group, the control group is a group of participants in the experiment that don't receive the treatment. Okay, so we don't change anything for this. When we're doing drug experimentation, right, there's always a control group that gets a placebo pill. They still get a pill, but it doesn't have the treatment, right? Nobody knows, right? Neither of the groups know if they're the placebo group or the experimenter group, where they are actually getting the experiment drug, right? So we see this a lot with new drugs, right? So in the control group, nothing has changed. They're given a placebo pill, or there's just no change. We don't give them any kind of treatment. Okay, that's the control group. Whereas the experimenter group gets the treatment, whatever that is. Okay, whether we're manipulating a variable, whether we're providing a drug, right? They're getting the actual experimental drug. if we use the example that I was talking about with feedback, right? So one group, let's say one group is an experiment group. We give them 100% accurate feedback, okay? Let's say we have another experiment group where we give them 50% accurate feedback, but then we have a control group where we just don't do anything at all, okay? And it's just, they know how to do the tasks and the number of tasks is just measured, but we don't give them feedback on right or wrong at all. Okay. That would be a control group. They would be just able to do it on their own. So here's an example of what that might look like. Well, let me see how much time I have. Yeah, this will be the last thing. A clinical psychologist conducts a study involving 10 people. Okay. He thinks he can cure depression by giving clients a particular type of pharmaceutical drug. He prescribed the drugs and finds that 60 days later, all clients show fewer signs of depression. The psychologist concludes he has cured depression. What is the problem here? No control group, right? So he has 10 people, he gives them all the same drug, and then he says, okay, none of them have depression anymore, and it's because of my drug. But he doesn't know that, because without the control group, you cannot rule out other explanations. Okay. Maybe life circumstances changed for all those 10 people. Maybe it wasn't just the drug. Maybe other things changed in their life, right? But we don't know that because there's not a control group that didn't get the drug, right? Because what we should see is if the control group who didn't get the drug should probably still be depressed. And the experiment group who got the drug shouldn't be depressed anymore. Now, if everyone is feeling better, including the people in the control group, okay, even though they didn't get the drug, they feel better, they're not depressed anymore, something's wrong. There was a confounding variable that all those people experienced that you did not account for. So you have to have a control group for any of your findings to be valid in something like this. Okay. That's it for today. I will have office hours. They will be online. I'll post a Zoom link. And that's it. If you have any questions, please let me know or shoot me an email. But I hope you guys have a good rest of the day. Don't forget that Thursday is your first quiz. We will do that in class online. Okay, on Zoom.
Thank you.
Have a good day, everyone.
Thank you.
Thank
Thank you.